Welcome to Grade 10, Unit 4, Straight Lines. This is Lesson 1, the distance between 2 points. This educational material was produced by E. Fanos, and I'm Jane, and I'm your teacher for this course. The objectives for this lesson are to define distance, and to know how to find the distance between 2 points on a plane. Distance between 2 points. Distance is a numerical description of how far apart two objects are. Distances are always positive, or zero if the points coincide. Here's a diagram. Here's the point -4, 2, and here's the point 2, 2. The distance between these 2 points is this length here from one point to the other point. It's how far apart these 2 points are. They have the same y-coordinate, so the distance between them is just a horizontal line. So this distance here is the difference between this x-coordinate 2 and this x-coordinate -4. The difference between them is 2 take away -4, which is 6. So the distance between these 2 points is 6. We can write this as one coordinate minus the other coordinate, and we use the absolute value symbols to show that we always take the positive value. Here's another point, 6, 2, and a point 6, -3. The distance between these 2 points is this length here. This time they have the same x-coordinate, so the distance between them is just the distance along this vertical line. The y-coordinate of this point is 2, and the y-coordinate of this point is -3. So the distance between them is 2 take away -3, which is 5. And we can write this as one y-coordinate minus the other y-coordinate, and we use the absolute value sign to show that we're always taking the positive value. Here's another example. This is the point -2, -2, and this is the point 2, 1. This time, the distance between these 2 points is the length of this diagonal line here. This time, the x-coordinates have changed and the y-coordinates have changed. So let's look at the x-coordinates and the y-coordinates separately. First of all, we can look at the x-coordinates. So the x-coordinate has gone from -2 up to +2. So the difference between the x-coordinates is -2 take away 2, which is 4. So that length is 4. Then we can look at the y-coordinates. The y-coordinate has changed from -2 to 1. So the difference between the y-coordinates is -2 take away 1, which is 3. So now we have this length, which is 4, and this length, which is 3. But what we want to find is this length here. We want to find the length of the diagonal line. So we need to use Pythagoras' theorem because we've got a right-angled triangle. Pythagoras' theorem says that a squared plus b squared equals c squared. So in this case, 3 squared plus 4 squared equals c squared. 25 equals c squared. 5 equals c. And notice that when we square root it, we ignore -5 because the distance can't be negative. So this distance here is 5. Let's do the same thing, but we'll use the general coordinates x1, y1 and x2, y2. This is so that we can come up with a general formula. So we create the triangle again, and this time this coordinate here is x2 because it matches this x-coordinate, y1 because it matches this y-coordinate. So the distance along here is x2 minus x1. And the distance up here is y2 minus y1. So now we have two sides of a right-angled triangle. We can use Pythagoras' theorem. A squared plus b squared equals c squared. So this means that x2 minus x1 squared plus y2 minus y1 squared equals c squared. But now we can remove the absolute value signs because when you square something, it's always positive anyway. So x2 minus x1 squared plus y2 minus y1 squared equals c squared. and then we can square root everything. C is the square root of x2 minus x1 squared plus y2 minus y1 squared. This is called the distance formula. Example. Find the distance between the points 3, -5 and -1, 4. This is the point x1, y1, and this is the point x2, y2. So if we use the distance formula, c is the square root of x2 minus x1 squared plus y2 minus y1 squared. So x2 minus x1 is -1 take away 3, and y2 minus y1 is 4 take away -5. So c is the square root of -4 squared plus 9 squared, which is the square root of 16 plus 81, which is the square root of 97. We can leave it like that if we want an exact distance, or we can work it out as a decimal to be approximately 9.85. Example. The distance between the points 1, 3 and 4a is 5. Find all the possible values of a. So again, this is the point x1, y1, and this is the point x2, y2, and 5 is the distance. So if we use the distance formula, c is the square root of x2 minus x1 squared plus y2 minus y1 squared, then x2 minus x1 is 4 minus 1, and y2 minus y1 is a minus 3, and the distance c is 5. So we've got 5 equals the square root of 4 minus 1 squared plus a minus 3 squared. And this simplifies to give 5 equals the square root of 9 plus a minus 3 squared. If we square both sides, we get 25 equals 9 plus a minus 3 squared. So 16 equals a minus 3 squared. So a minus 3, the absolute value of this, must be 4. Or in other words, a minus 3 is 4, or a minus 3 is -4. Solving this gives a is 7, or a is -1. So these are the two possible values for a. Example. An equilateral triangle has two vertices at p -6, 2 and q 6, 2. What could the coordinate of the third vertex be? Let R be the third vertex with coordinate xy. In this case, a diagram always helps. So here's our diagram, and we can see that P and Q have the same y coordinate. So the line from P to Q is a horizontal line. And here's our unknown coordinate R. The distance from P to Q is 6 take away -6, which is 12. Also, if we draw a line of symmetry down the middle of the triangle, we can see that x, this x coordinate here, must be 0 because it must be halfway between -6 and +6. So now we can use the distance formula on the distance between P and R. So we know that the distance must be 12 because it's an equilateral triangle, so all the sides have length 12. So we put 12 here for the distance. Then we do x2 minus x1, so in this case that's x, which is 0, take away -6. And then we do y2 minus y1. In this case that's y, which we don't know the value of, take away 2. So 12 equals the square root of 0 take away -6 squared plus y take away 2 squared. If we square both sides, we get 144 equals 36 plus y minus 2 squared. So 98 equals y minus 2 squared. If we square root this, then we get plus or minus 7 root 2 equals y minus 2. The plus or minus is important because when you square root something, you could either get the positive answer or the negative answer. If we solve this, we get that y is 2 plus or minus 7 root 2. We already knew that x was 0, so now we found all the possible values for this coordinate. It's either 0, 2 plus 7 root 2, or 0, 2 minus 7 root 2. So it's either up here or it's at the mirror image down here. Example, let P, which is 5, 4 root 11, and Q, which is negative 5, 2 root 11, be two opposite vertices of a square. Calculate the area and perimeter of the square. In this case, it's going to help to draw a diagram. So here's our square with side length S. We don't know what the side length is yet. Here are our 2 points P and Q. Q is negative 5, 2 root 11, and P is positive 5, 4 root 11. And here's the diagonal D across the square, which joins P and Q together. We've got two formulas for the area of a square, either A equals S squared, where S is the side length, or A equals D squared over 2, where D is the diagonal. Let's use the distance formula to find the length of this diagonal. So the length from P to Q is the square root of x2 minus x1 squared, which is 5 take away negative 5 squared, plus y2 minus y1 squared, which is 4 root 11 minus 2 root 11 squared. If we simplify this, we get that PQ equals 10 squared plus 2 root 11 squared. So PQ is the square root of 100 plus 44. So PQ equals 12. The diagonal of this square is 12. Now if we use the area formula d squared over 2, we can calculate that the area is 12 squared over 2, which is 144 over 2, which is 72. We were asked to calculate the area and the perimeter, so let's do the perimeter next. To do the perimeter, we need to know what the side length is. We can find the side length by doing the square root of the area, so the square root of 72, which is 6 root 2. The perimeter is then 4 times 6 root 2, which is 24 root 2, because there are 4 sides to the square. Example. Does a plane figure with vertices A equals negative 3, 4, B equals 5, 7, and C equals negative 9, 11 represent a right-angled triangle? If it's a right-angled triangle, then we should be able to use Pythagoras' theorem, a squared plus b squared equals c squared. So let's find all the distances between a and b and c and A, and see if they fit into Pythagoras' theorem. First of all, AB. This is 5 take away negative 3 squared plus 7 take away 4 squared, all square rooted, which is the square root of 73. BC is the square root of 5 take away negative 9 squared plus 7 take away 11 squared, which is the square root of 212. AC is the square root of negative 3 take away negative 9 squared plus 4 take away 11 squared, which is the square root of 85. So now let's see if that fits into Pythagoras' theorem. The square root of 212 is the biggest value, so this would have to match up with C. So we want to check if the square root of 73 squared plus the square root of 85 squared is equal to the square root of 212 squared. And to do this, we just need to check if 73 plus 85 equals 212. No, it doesn't. So no, this plane figure does not represent a right-angled triangle. Summary. Distance is a numerical description of how far apart two objects are. Distance is always non-negative. If 2 points coincide, that means that they are the same point. Then the distance between them will be 0. The distance d between points A equals x1, y1 and B equals x2, y2 is given by the formula d is the square root of x2 minus x1 squared plus y2 minus y1 squared. Review questions 1. Find the distance between the two given points. Pause the video whilst you work them out. Here are the answers. A is 13, B is the square root of 29, For C, we end up with the square root of the square root of 2 squared plus the square root of 2 squared, which is the square root of 2 plus 2, which is the square root of 4, so the distance is 2. For D, we end up with the square root of 2 root 5 squared plus root 5 squared, which is the square root of 20 plus 5, which is 5. For E, we end up with the square root of root 2 over 2 squared plus root 2 over 2 squared, which is the square root of 2 over 4 plus 2 over 4, which is 1. Review questions 2. The coordinates of A, B and C are 5, 4, negative 1, 2 and 3, negative 2 respectively. Find the perimeter of triangle ABC. 2. Let P, negative 5, negative 2 and Q, 7, 3 be two adjacent vertices of a square. Calculate the area and perimeter of the square. Pause the video whilst you work out the answers. Here are the answers. The distance from A to B is the square root of 40, or 2 root 10. From B to C is root 32, or 4 root 2. And from A to C is root 40, or 2 root 10. If we add all of that up, then the perimeter is 4 times root 10 plus root 2. For number 2, the distance between P and Q is the square root of 144 plus 25, which is 13. So the area is 169 units squared, and the perimeter is 52 units. Review questions 3. An equilateral triangle has two vertices at P, negative 5, 1 and Q, 5, 1. What could the coordinate of the third vertex be? 2. Let P equal 5, negative 4 and Q equal negative 1, 4 be two opposite vertices of a square. Calculate the area and perimeter of the square. Pause the video whilst you work out the answers. Here are the answers. For number 1, the distance from P to Q is 10. The x-coordinate must be 0. And then the distance formula tells us that y minus 1 squared plus 25 equals 100. So y minus 1 is the square root of 75, which is 5 root 3. So y minus 1 is 5 root 3, or y minus 1 is negative 5 root 3. So the coordinates are 0, 1 plus 5 root 3, or 0, 1 minus 5 root 3. For question 2, the distance from P to Q is 10. The area is 50 units squared. The side length is the square root of 50, which is 5 root 2. And the perimeter is 20 root 2 units. Part 4. The distance between the points 7a and 1, 9 is 10. Find all possible values of a. 2. Find the distance between root 3ac and negative root 3bc. 3. Find the distance between root 3a negative a and negative root 3a a. Pause the video whilst you work out the answers. Here are the answers. 1. A is 17 or a is 1. 2. The distance is root 3 times the absolute value of a plus b. 3. The distance is the square root of 2a squared plus 2 root 3a squared, which is the square root of 4a squared plus 12a squared, which is the square root of 16a squared, which is 4 times the absolute value of a. Part 5. The distance between the points 7, 5a and 1a is 10. Find all possible values of a. 2. The distance between the points 2x plus 1, 4 and x plus 3, 0 is 5. Find all possible values of x. Pause the video whilst you work out the answers. Here are the answers. A is 2 or a is negative 2. The square root of x minus 2 squared plus 4 squared is 5. So this means that the square root of x squared minus 4x plus 4 plus 16 is 5. So x squared minus 4x plus 20 is 25 if we square root both sides. So x squared minus 4x minus 5 equals 0. So x minus 5 times x plus 1 equals 0. So x equals 5, or x equals negative 1. This is the end of lesson 1. The objectives for this lesson are to know and understand the section formula, and to use the section formula to find a point that divides a line segment into a given ratio. Also to find the midpoint of a line segment. Division of a line segment. Here's a point A, x1, y1 and a point B, x2, y2. Let's try and divide this line into two parts using this point here, C, xy. If the ratio of the two parts is m to n, then we can create a triangle here using the coordinate E, which is x2, to match this coordinate, and y to match this coordinate. And we can create a triangle here using the point F, x, y1, where x matches this coordinate and y1 matches this coordinate. Then this angle here and this angle here are the same because they're corresponding angles. And these two triangles both have a right angle. So the triangles must be similar because all the angles in one triangle are the same as all the angles in the other triangle. So triangle AFC is similar to triangle CEB. We're now going to try and use this fact to come up with a general formula for the coordinates C, x, y. Because the triangles are similar, we can write down that the ratios of the sides are equal. In other words, x minus x1, which is this distance here, over x2 minus x, which is this distance here, is the same as m, this length here, over n, this length here, which is the same as y minus y1, this length here, over y2 minus y, this length here. We're trying to come up with a formula for x, y, so we can use this first part to come up with a formula for x. If we multiply by the denominators, we get nx minus nx1 equals mx2 minus mx. If we get all the x's on the left and everything else on the right, we get nx plus mx equals mx2 plus nx1. And factorise, x times n plus m equals mx2 plus nx1. So x equals mx2 plus nx1 over n plus m. And now we can use the other side to find a general formula for y. So we get ny minus ny1 equals my2 minus my. So ny plus my equals my2 plus ny1. And factorise gives y times n plus m equals my2 plus ny1. So y equals my2 plus ny1 over n plus m. And we've now got a general formula for the coordinate C, x, y that divides this line segment into the ratio m to n. To summarise that, to divide this line segment into two parts in the ratio m to n, then we need to use the coordinate C, x, y, where x equals mx2 plus nx1 over n plus m, and y equals my2 plus ny1 over n plus m. So just to have a look at what that means, it means that we multiply m by x2 and we multiply n by x1. So it's almost like we're multiplying by the opposite coordinate. And in both cases, we divide by the total of the ratio, which is m plus n. Example. Find the coordinates of the point that divides the line segment with endpoints p, 3, negative 4, and q, 1, 6, in the ratio 1 to 2. Let's start by drawing a picture. Here's p, 3, negative 4, and here's q, 1, 6. It's been divided into the ratio 1 to 2, using this coordinate here, r, which is xy. We're trying to find xy. If we use the formula, then we need to do 1 times 1 plus 2 times 3 over the total, which is 1 plus 2, to find the x-coordinate, which is 7 over 3. And then for the y-coordinate, we need to do 1 times 6 plus 2 times negative 4 over the total, which is 1 plus 2. And this gives us negative 2 over 3. So R is the point 7 over 3, negative 2 over 3. Example. Find the point that is 1/4 of the way from 2, 4 to 10, 8. Here's the diagram again, going from 2, 4 to 10, 8. And we want the point R, xy, which is 1/4 of the way along. So it must divide the line segment into the ratio 1 to 3. Using the formula, we want 1 times 10 plus 3 times 2 over 1 plus 3, which is 16 over 4. And we want the point 1 times 8 plus 3 times 4 over the total 1 plus 3, which is 20 over 4. So R is the point 4, 5. Midpoint. This time, let's have 2 points A, x1, y1 and B, x2, y2. And now let's try and divide the line segment exactly in half, so in the ratio 1 to 1. And we'll use the point mxy as the midpoint of this line. If we use our formula, mx2 plus nx1 over n plus m, and my2 plus ny1 over n plus m, then in this case, m and n are both 1, because the ratio is 1 to 1. So x is 1 times x2 plus 1 times x1 over 1 plus 1. And y is 1 times y2 plus 1 times y1 over 1 plus 1. So x is x2 plus x1 over 2, and y is y2 plus y1 over 2. The midpoint of the line segment joining x1, y1 and x2, y2 is given by m equals x1 plus x2 over 2, y1 plus y2 over 2. This is like the mean average of x1 and x2, and this is like the mean average of y1 and y2.